When you're first introduced to natural language processing, one of the first tasks that you're likely to encounter is sentiment analysis. Sentiment analysis is a process in natural language processing to detect and interpret emotional responses in text. The primary goal of sentiment analysis is to automatically classify and understand whether the sentiment expressed in the text is positive, negative, neutral, or sometimes even more fine grained, such as very positive or very negative. Sentiment analysis involves identifying and categorizing opinions expressed in text to determine whether the writer's attitude is positive, negative, or neutral. This helps in understanding the sentiments, emotions, or attitudes expressed in text data. Sentiment analysis is widely used in business for brand monitoring, product analysis, and market research. It allows companies to gauge customer sentiment from reviews and social media. It's also used in political campaigns to assess public opinion and in customer service to automate responses. Accurately interpreting sentiment can be challenging due to the nuances of the human language. It's hard for machines to identify sarcasm, idioms, and context dependent meanings. Advanced techniques in machine learning and natural language processing are typically employed to improve accuracy and handle these complexities. There are two broad approaches one can take to perform sentiment analysis. Lexical approaches aim to map words to sentiment by building a lexicon or dictionary of sentiment scores. We can then use the dictionary to assess the sentiment of phrases and sentences and sum up the scores of individual words to get the overall sentiment of the piece of text. One major advantage of lexical approaches lies in the fact that we do not need to train a model using labeled data, since we have everything needed to assess the sentiment of sentences in our dictionary of emotions. And then we have machine learning approaches. These involve models that have looked at previously labeled training data in order to gauge the sentiment of instances that they've never seen before, text that they've never seen before. With machine learning, greater the volume of our training data, generally better predictions or classification results from the model. But with machine learning approaches, we need labeled data for training, which might be hard to come by. Let's discuss lexical approaches in more detail. Lexical methods rely on predefined lists of words with associated sentiment scores. These lists, called sentiment lexicons, may include words categorized as positive, negative, or neutral. Lexical systems are rule based systems. They apply rules to the text based on the sentiment lexicons. The rules could maybe just count the number of positive and negative words to determine the overall scores. Rules can also be more nuanced. They can consider intensifiers or negations. Very happy is that's an intensifier, not happy is a negation. Lexical approaches have their limitations. They struggle with context and ambiguity and may not accurately capture sentiment in sentences where the meaning is not clear cut or is dependent on specific knowledge of context. They can also miss out on nuances like sarcasm or idioms. Let's now briefly discuss machine learning approaches to sentiment analysis. Sentiment analysis is a supervised learning problem. It's essentially a classification problem where your model is trained on a large labeled dataset. The models learn from the data and then predict sentiment for new unseen text. Deep learning models in machine learning can capture nuances in language, including the impact of word order and the presence of sarcasm or irony. They tend to be far more powerful models capable of advanced analysis. However, one challenge is that these techniques require large, well labeled datasets for training, which can be resource intensive to create. We look at machine learning for sentiment analysis a little later on in this learning path. Here I'll discuss a rule-based approach to sentiment analysis using VADA. VADA here is an acronym for Valence Aware Dictionary for Sentiment Reasoning. This is a rule-based sentiment analysis system that is sensitive to both polarity and the intensity of the emotion. Polarity can be positive, negative, neutral, and the intensity is the degree of positivity or negativity. VADA is specifically designed to analyze sentiment in social media text and is great at handling informal language, slang, emoticons, and other idiosyncrasies commonly found in social media. Veda makes use of a lexicon of sentiment related words with a set of 5 heuristic rules to quantify the sentiment of a text. Each word in the lexicon is rated as positive or negative and assigned an intensity score. Veda sentiment analysis relies on a dictionary which maps lexical features to emotion intensities called sentiment scores. The sentiment scores of a text can be obtained by summing up the intensity of each word in the text, and Veda produces 4 sentiment metrics from its analysis: positive, neutral, negative, and a composite score. Veda is widely used and valued for its ease of use, efficiency, and the fact that it does not need labeled training data. It just makes use of all of the entries in its lexicon to assess the sentiment of language, and it's able to capture many nuances as well. Veda has the ability to understand the nuances of internet language, such as emoticons and slang. Veda sentiment analysis considers 5 heuristics to consider contextual elements like punctuation, capitalization, and modifiers, which also impart emotion. The first is punctuation. Great without the exclamation is less positive than great with the exclamation score. The second heuristic has to do with capitalization. The word amazing in capital letters will get a higher sentiment score than amazing without the capitalization. The third heuristic has to do with degree modifiers. Great job is definitely more positive versus good job. And Veda will assess the sentiment score accordingly based on the modifier. Veda also accounts for shift in polarity in a sentence because of the presence of the word but. I enjoyed the experience, but the service was poor. The terms after the but are more important than the terms before the but. And finally, Veda uses trigrams to catch polarity negation. Trigrams are sequences of 3 contiguous words to catch negation that may exist in text.